Assalamualaikum warahmatullahi ta'ala wabarakatuh, and a very good morning to all. Please welcome to the opening ceremony of International Conference on Bioengineering and Technology, IConBET2021. Ladies and gentlemen, to begin with, I would like to call upon Yang Berusaha Dr. Arzfi Zaidi bin Muhammad Sofi for Doa recitation. Please welcome.
Alhamdulillah Rabbil Alamin. Wassalatu wassalamu ala Sayyidina Muhammad Ashrafil Anbiya wa Mursalin wa ala alihi wa sahbihi ajma'in. Ya Allah, Ya Rahman, Ya Rahim. We express our gratitude to you for allowing us to attend the launching ceremony of International Conference on Bioengineering and Technology, IConBET 2021, on this auspicious morning. Ya Allah, we ask you for the safety of our religion and the welfare of our body, O Allah, Lord of the implementing authority. Make the days that we've gone through, starting with your mercy, continue us with your blessing, and end up with thy forgiveness. And also make the days that we've gone through with guidance, and end with the victory of excellence. Ya Allah, Ya Muhaimin, Ya Aziz, Ya Jabbar, let our effort as a mean to enlighten and convince ourselves that the personal safety of either outer or inner is a prerequisite for achieving happiness and excellence in various fields. O Allah, grant us faith and strength in order to face the challenge of life during this transition period and in the phase of life in this new millennium. Ya Allah, Ya Farija Hami wa Ya Kashifa Gami. Ya Allah, show us guidance and adjust our path and ways to achieve happiness and glory. Let us to listen to people who like the good things. Let us avoid doing the bad and evil things. Oh Allah, bless our life in this meeting and gathering and prevent us from harm and unfortunate event. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina azabannar. Wa qina azabannar. Amin.
Amin. Amin, amin ya Rabbal Alamin. Thank you, Dr. Arzfi Zaidi bin Muhammad Sofi. Yang berbahagia, Profesor Datuk Dr. Nur Azizi bin Ismail, Vice Chancellor, Universiti Malaysia Kelantan. Yang berbahagia, Profesor Teknologis Dr. Arham bin Abdullah, Deputy Vice Chancellor of Research and Innovation, Universiti Malaysia Kelantan. Yang berbahagia, Profesor Insinyur Teknologis Dr. Ahmad Ziad bin Sulaiman, Advisor of IConBET 2021. Yang berusaha, Associate Professor Dr. Nur Azlina binti Ibrahim, Dean of Faculty of Bioengineering and Technology, Universiti Malaysia Kelantan. Technologist Dr. Sarizam bin Mamat, Chairperson of IConBET 2021. Keynote speakers, directors, dean and deputy deans, our sponsors, organizing committee, and all the participants of IConBET 2021. Welcome again to the International Conference on Bioengineering and Technology 2021. First and foremost, on behalf of the organizing committee, I would like to extend our warmest welcome to our distinguished keynote speakers, invited speakers, presenters, participants, ladies and gentlemen. It is a great pleasure to have all of you joining us here on this occasion virtually. Ladies and gentlemen, today, the International Conference on Bioengineering and Technology, IConBET 2021, is the first virtual international conference ever conducted by our faculty, Faculty of Bioengineering and Technology. It's my pleasure to walk you through the conference, introduce you to the establishment of our faculty. Situated in green and peaceful town of Jeli, Kelantan, the faculty was established in 2017 and currently offering three undergraduate academic programs, which are Bioindustrial Technology, Material Technology, and Forest Resources Technology. We are also offering postgraduate programs in various science and technology areas. Everyone, we are most welcome to come and be part of our family in Jeli, Kelantan, Malaysia. Ladies and gentlemen, the presentation for today's conference will feature both synchronous and asynchronous mode, which include over 200 presenters across the globe. This conference is committed to provide a great opportunity for all the academicians, scientists, researchers, technologists, students, and industry representatives ranging in the field of bioengineering, biology, chemistry, physics, environment, and entrepreneurship. We hope all the participants will gain and sharing a joyful knowledge and experience throughout this conference. Therefore, I would like to encourage the presenters and participants to participate in all the activities and discussions through the digital platforms for today and tomorrow. I wish everyone a successful, safe, and fruitful conference. Ladies and gentlemen, without further ado, I would like to invite the chairpersons of IConBET 2021, Yang Berusaha Technologist Dr. Sarizam bin Mahmad, to deliver the welcoming speech. Please welcome.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and very good morning. Thank you for our MC Dr. Nurul Akmal binti Cik Zaudin. Yang berbahagia Profesor Datuk Dr. Nur Azizi bin Ismail, Vice Chancellor Universiti Malaysia Kelantan. Yang berbahagia Profesor Teknologis Dr. Arham bin Abdullah, Deputy Vice Chancellor of Research and Innovation, Universiti Malaysia Kelantan. Yang berbahagia Profesor Insinyur Teknologis Dr. Ahmad Ziad bin Sulaiman, our advisor of IConBET 2021. Yang berusaha Associate Professor Dr. Nur Azlina binti Ibrahim, Dean Faculty of Bioengineering and Technology, keynote speakers, invited speakers, directors, Dean, Deputy Dean, all sponsors, member of the IConBET 2021 organizing committee, and all participants of IConBET 2021. Ladies and gentlemen, Alhamdulillah, thanks to Almighty Allah Subhanahu Wa Taala for giving us the opportunity to gather together here this morning for the IConBET 2021. On behalf of the organizing committee, I would like to extend a very warm welcome to participants of the IConBET 2021. I believe the international conference will provide a great opportunity and platform for the exchange of ideas and knowledge among researchers. Even better if it can resemble a program to promote collaboration among researchers towards the green technology, innovation with an entrepreneurial implementation. Ladies and gentlemen, in line with the theme of this conference, reimagining innovation in sustainability through green technology for entrepreneurial society development, is important in chalking up new milestones in the pursuit of new knowledge and technological advancement. I really hope that you will have memorable experience, and I sincerely hope all the presentations from the keynote, invited speakers, and presenters during the conference will come in useful as added value to your current knowledge. I am confident that all participants will open up and access to the new technology knowledge discovery, especially in bioengineering, on the public attention, while promoting entrepreneurship sense for a sustainable tomorrow. I would also like to take this opportunity to thank the committee who have worked very hard to make this international conference a success. Thank you also to all presenters and participants, especially local and international, for your contributions. Thank you very much.
Thank you, Yang Berusaha, Doctor, for the speech. Now, I would like to invite Yang Berbahagia, Professor Datuk Dr. Nur Azizi bin Ismail, Vice Chancellor of University Malaysia Kelantan, to deliver his welcoming remark and to officiate IConBET 2021. Please welcome.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning to everyone. Yang berbahagia Profesor Insinyur Dr. Muhammad Safwan Saleh from University Putra Malaysia and Professor Dr. Yusuf Kisti from Masih University New Zealand, keynote speakers for first international conference on bioengineering and technology 2021. Yang berbahagia Profesor T.S. Dr. Arham Abdullah, Deputy Vice Chancellor, Research and Innovation. Yang berusaha Associate Professor Dr. Nur Azlina Ibrahim, Dean Faculty of Bioengineering and Technology. Yang berusaha T.S. Dr. Sariza Mahmad, the Chairman of IConBET 2021, invited speakers, distinguished guests, ladies and gentlemen. First and foremost, I would like to extend a warm welcome to all the participants of the International Conference on Bioengineering and Technology 2021, or IConBET 2021, which is held virtually this year due to the COVID-19 pandemic. I would like to congratulate the Faculty of Bioengineering and Technology of University Malaysia Kelantan for successfully organizing this very significant event. I would also like to convey our heartfelt gratitude to Broker Malaysia Sdn Berhad, the gold sponsor, Kopi Mesin Kota Baru as the silver sponsor, as well as InnoLab Engineering Sdn Berhad, Gaya Science Sdn Berhad Malaysia, and NIFA Biotech Industry Sdn Berhad for their sponsor and support the IConBET 2021. IConBET 2021 highlights the faculty's vision and mission to prioritize technology innovation within entrepreneurial framework. It also serves as a medium to expose our young and senior researchers to establish collaborations with fellow academia and practitioners. Therefore, the purpose fits well with the conference theme, reimagining innovation in sustainability through green technology for entrepreneurial society development. Even though this event is held in virtual mode, I am sure we can still effectively contribute by asking questions, giving opinions, and exchanging our expertise with one another. Therefore, I would like to take this opportunity to also congratulate all 204 local and international participants. This year, we have participants from many countries, including Singapore, Indonesia, Thailand, Japan, New Zealand, Australia, India, Nepal, Libya, Oman, Cyprus, as well as Malaysia. Your active participations will ensure the success of this conference. Last but not least, I hope that everyone will gain invaluable insights and knowledge from this event. On that note, it gives me great pleasure to officiate the opening of the International Conference on Bioengineering and Technology 2021. Thank you.
Thank you, Yang Berbahagia Prof, for the speech. Ladies and gentlemen, IConBET2021 is now officially started. I would also like to take this opportunity to extend my utmost appreciation to everyone who have been involved in making this virtual conference a success. Most importantly, on behalf of University Malaysia Kelantan, I would like to wish the participants of IConBET 2021 a meaningful and productive day ahead. I am glad to remind the participants again that we will have keynote session after this, and please stay online till the end of the ceremony. The keynote speech will be delivered by Yang Berbahagia Professor Insinyur Dr. Muhammad Safwan Saleh from University Putra Malaysia. For tomorrow, we will have another keynote session with Professor Dr. Yusuf Christie from Massey University, New Zealand. Kindly stay tuned with us. The keynote speech will be aired through main room of Microsoft Teams. Please see the link below. The link is also available at program tentative that have been sent to all the participants. Alternatively, you may also stream the keynote session through UMK Facebook page as well as our faculty's Facebook page, FBKT. After the keynote session, please kindly proceed to the oral parallel session at Room 1, Room 2, Room 3, and Room 4 of Microsoft Teams. The link is also available at the program tentative. Alternatively, you may also watch the oral parallel session through our faculty Facebook page. On this note, I would also like to remind all of the participants that we will have a prize-giving ceremony for Best Oral Presenter and Best Poster Presenter during the closing ceremony. Ladies and gentlemen, in conjunction to this conference, the organizing committee has organized a photo competition with the theme Wonders of Science, Technology, Engineering and Mathematics, STEM. The competition was open to all Malaysians. We have received almost 200 photos, and tomorrow we will announce the lucky winners. Stay tuned with us. Ladies and gentlemen, we shall now proceed to our next agenda, which is Keynote Sessions. For that, I will hand over the floor to Yang Berusaha Associate Professor, Technologist Dr. Muhammad Hasnizam bin Razali from University Malaysia Terengganu to chair this keynote session. For your information, the keynote session will start at 9:30 a.m. today. Please stay with us in the same channel. With that, I end our opening ceremony this morning with Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi ta'ala wabarakatuh. See you tomorrow for the closing ceremony.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, before we start the presentations, and in order to avoid any disturbance during the presentation later, I would like to ask you to change the mood of your Microsoft Teams into silence. Right? Thank you. Right. Again, thank you very much to Master of Ceremony, the Honorables, the Vice Chancellor of Universiti Malaysia Kelantan UMK, yang berbahagia Profesor Datuk TS Dr. Nur Azizi bin Ismail, the Deputy Vice Chancellor Academic and International Affairs of UMK, yang berbahagia Profesor Dr. Muhammad Rafi bin Yaakob, the Deputy Vice Chancellor Student Affairs and Alumni of UMK, yang berbahagia Profesor Dr. Razli bin Cik Razak, the Deputy Vice Chancellor Research and Innovation of UMK, yang berbahagia Profesor Teknologis Dr. Arham bin Abdullah, the Dean of Faculty Bioengineering and Technology, Associate Professor Dr. Nur Azina binti Ibrahim, all the Deans and Director at UMK, our keynote speaker, distinguished guests, fellow students, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh and good morning. Okay, I would like to take this opportunity first of all to welcome you all to this distinguished event, International Conference of Bioengineering and Technology, IConBET2021. A million thanks greet to the organizer, Office of Research and Innovation UMK, the Faculty of Bioengineering and Technology, Jili Campus, and all the committee members for organizing a great event this morning. In these occasions, we shall have outstanding presentations from our prominent presenter, whom I believe shall enrich our insight and knowledge regarding the themes of this keynote lecture. Okay, so before the presentation begins, allow me to introduce our speaker, our first keynote speaker, Professor Muhammad Safwan Saleh. All right. Okay, so Muhammad Safwan Saleh is a professor of composite materials at University Putra, Malaysia. He earned his bachelor degree in mechanical engineering from University of Newcastle, Australia in 1990, and then they proceed his master and PhD in UK. All right, so basically his research interests include natural fiber composite, biocomposite, material selections, and concurrent engineering. Until to date, he has authored or co-authored more than 1,500 publications, including 800 journal papers, 18 authors book, 35 edited book, so on and so forth. His achievement is very excellent. All right. So Muhammad Safwan was the recipient of Rhetoric Research Gold Medal Award 2012. Okay. Khwarizmi International Award, KIA. And then in 2013, he has awarded the 5-star Role Model Supervisor Award by UPM. And then he has been conferred fellowships by the US-based Society of Automotive Engineers International in 2015. Okay, again, he also received citation of Excellent Award from Emerald UK, Best Paper Award by Chinese Defense Ordnance, Malaysian Research Star Award MRSA, Top Research Scientist Malaysia Award, and Professor Eminence Award from AMU India, and recently listed in the top 2% world scientists by Stanford University in USA. Okay, they have a lot of achievement by Prof. Muhammad Safwan Saleh. Okay, without further ado, I would like to welcome our presenter. He will deliver a presentation entitled Engineering Biocomposite Transforming Toward Circular Economy. Okay, ladies and gentlemen, please welcome Professor Muhammad Safwan Saleh. Over to you, Prof.
Thank you, Dr. Muhammad Hasmizam. I would like to share first my PowerPoint. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and very good morning to most of you, and to some of you maybe good afternoon and good evening in different part of the world. Okay, first of all, I would like to thank University Malaysia Kelantan, Jelly Campus, for inviting me to deliver a keynote lecture in the IConBET2021. I'm so glad and so honored to be invited. And I would like to thank all the management of UMK and the organizing committee for this invitation. Okay, as mentioned by the chairperson, that the lecture title is Engineering Biocomposite Transforming Towards Circular Economy. The lecture outline, I will start with introduction, where I will discuss different topics on the development of biocomposite product in different industries, mainly that we ourselves involved in the development. And since we are now in the pandemic, COVID-19 pandemic, I will review some work on the biocomposites, as well as the constituent of biocomposite, meaning natural fiber, as well as the biopolymer to develop biocomposite, or meaning during the COVID-19 pandemic. And we have done some work on biocomposite product during this pandemic, and which is biochar, biocomposite char, and I will review some of book publication, and also I will conclude my lecture. Okay, as introduction, we see that in the pictures, the plastic bags and packaging, they are being used a lot in our daily life, and we always talk about the problem associated with that, which is the plastic waste, and they are non-biodegradables and will remain in the nature for a long time, hundred and thousands of years, and it will affect our life and also the marine life, for instance, the animals who will suffer. So despite the numerous merit attached to the use of petroleum-based plastic, they, in short, bring the severe environmental impact. The non-biodegradable nature of the petroleum-based plastic has the pose great environmental challenges which contributes to the rapid exhaustion of landfill. So the growing awareness toward the environment has directed in the attention of most researchers to eco-friendly materials, which are attributed to the terms such as renewables, recyclable, sustainable, biodegradables, greens materials, So the lecture today will focus on the development of the green materials, green composite. And when you talk about green material and green composite, there are two issues here. Two things rather. One is on the 100% fully biodegradable biopolymer composite, which is 100%, from plant-based or animal-based. But there are something also that partially, where most of the time the matrix is made from the synthetic, but the fiber are made from the natural fiber in composite. But both topic will be dealt in this lecture. Okay, since my part of the title is on circular economy, I will, just show, and it's taken from Wikipedia, the definition of circular economy. And it is an economic system aimed at eliminating waste and the continual use of resources. And circular system employ reuse, sharing, repair, refurbishment, remanufacturing, and recycling to create closed-loop system, minimizing the use of resource input and the creation of waste, pollution, and carbon emission. So basically, we want to make full use of the waste, the residue, the agricultural residue, agricultural byproduct to transform into valuables, things, and into wealth. And not only that, it can be recycled, and to make into product. So this is the topic that is nowadays it has been discussed a lot. So we believe that the work that we have done, that we are doing, is in line with this thinking. So it's not going to be detail of my lecture on this circular economy, but we said just our work is gearing toward those ends. Okay, this is the main topic that I want to discuss in this lecture. Now, I introduce the term natural fiber reinforced polymer composite. In my title, that I mentioned about biocomposite. Well, they are the same thing, really. Composite is the main thing, but bio is anything that comes from nature, from plant, animals. We call bio. And natural fiber is more specific to the fiber that come from plant and from the animals. Whereas the polymer, which is a matrix for the composite, as I mentioned, could be from bio-based as well as in synthetic polymers. So it is difficult to have the product, particularly the product that the structural product that use 100% bio-based polymer composite. That's why we need really to still to defend on the synthetic polymer, but at least we have the fiber reinforcement made from natural fibers. So it can be considered, still being considered as biocomposite. Okay, the natural fiber, they could be in purely the reinforcing has got some strength and ability to resist some load, etc. But some natural fibers, they are just act as a fillers in the biopolymer composite. So the polymers as we know, are divided into thermoset and thermoplastic, and including biopolymers. And this is the focus of work in the recent years, using starch-based biopolymer that we develop in-house, or we can also work on biopolymer which is commercially available, notably polylactic acid. And polylactic acid is such a good material that has got some strength, and when we mix with the natural fibers, and they can become very good product and can be used in some component. I've read it has been used in the bus body and other product. Of course, the cost of PLA a bit expensive. Okay, natural fiber, which is the one of the constituents of a natural fiber composite or biopolymer composite, biocomposite, is a fiber which grows or develop and come from natural resource like plants and animals. Even our recent research work is on the cow horn. Is used as the fiber for metal matrix composite. So plants, of course, a lot of plants has been used as a natural fiber, and in the past we read that the plants like sisals, jute, kenaf, which is found abroad those days, and hemp. But nowadays, the plants that's available in Malaysia, they are being used a lot as fiber reinforcement in biopolymer composite like kenaf. We have now the kenaf and tobacco board of Malaysia, and the oil palm. You are rich with that natural resources, and others as well that is available in our country like sugarcane bagas, even banana pseudostem, the coconut from coconuts and coir and shell, and these are the example of the natural fibers that are really can be used as a reinforcement in biopolymer composite. Okay, natural fiber, as I mentioned, can be divided broadly into an animal-based and vegetable-based, mostly vegetable-based, from seed like cotton, from inner bark like flax, hemp, jute, kenaf, rami, from leaf, abaca, sisals, and from fruits like from the coconuts, cocoa. And we can use also the natural fiber from animals like from silks and from wool's, animal hair, horse hair. I just mentioned about the cow horn, and we have even chitosan. This is from animals that is used for composite constituent as well. Seashells, and they're also the good source of natural fibers. Okay, the advantages of natural fiber compared to synthetic fibers, and in terms of weight, of course, natural fiber is lightweight. Synthetic fiber like glass and carbon normally twice that of natural fiber in terms of density, weight, cost. And natural fiber is of low cost and no cost. You can get, sometimes you can get it for free. And obviously, synthetic fiber is much expensive, particularly when talking about glass fiber. Aramide fiber is very, very expensive, really. Renewability, and this is maybe good. The selling point of natural fiber, it is renewables, recyclables, and biodegradables, and it is I mean, it doesn't pose on health concern. There's no health concern associated to that, and widely distributed. We can find it a lot in our country, particularly as a tropical country. We are blessed with abundant resources of natural fiber, whereas synthetic fiber, they are not renewables, not recyclable, and has posed a health problem, and not biodegradable. I mean, disposal is, yes, it can be disposed, but not biodegradable, meaning that we didn't say that the synthetic fiber is bad. They are being used in most of the product, and they have got different, attributes like very high strength and also stiffness, and they are being used in most important product, or like in aircraft body, in our cars, But natural fibers, give some alternative to certain application, uh, you know, that may not require very high strength and in a highly loaded component, non-structural component. Okay, look at the product that we find in our country now, Knaf, and oil palm and sugar palm. Sugar palm is really the product that is not familiar with many of you, but I think the plant is available, and we at UPM, we do some pioneering work on sugar palm. It is pokok now really in bahasa in bahasa. I think UMK also has done some work on sugar palm. So if we compare, for example, the tensile strength of natural fiber that we have, like Knaf and oil palm and sugar palm, they are not really different from the existing, the established natural fiber like flax, hemp. They are comparable really in terms of strength as well as in terms of stiffness. Okay, I will focus on, as I highlighted in the earlier slide, that three main resources that we have in our country. One is oil palm. So on the left hand side is the plant, that the trees that we normally saw. On the right hand side, the bunch. But through the research, we want to develop the fibers, and they are available now in the market, but we want to make them into product. Okay, a bund is taken from, I think, MPOB, this slide. Abundance of oil palm biomass, which is 10% is for oil, but 90% for biomass. And from there, we can have the oil palm front, fresh fruit bunch, oil palm trunk. And from the fresh fruit bunch, fruit bunch, we can have palm kernel cake, shell, empty fruit bunch, which is 22%, and fiber 13.5%. And fiber normally used for foam, and palm kernel also used for oil and for other purpose. Okay, we focus more on fiber from the oil palm. So from the oil palm front, we can have oil palm front fiber, which is 70%, empty fruit bunch 10%, the fiber, and oil palm trunk fiber is 5% from the entire plant. Okay, I will focus on our work at UPM, as well as with our co-researchers from different organizations, funded by Sime Darby, on oil palm fiber composite safety helmet. The reason I want to focus on this, that I want to highlight that natural fiber composite, they are potentially can be used. They potentially can be used in our day-to-day life, in engineering product, in important component. So this work was funded by Sime Darby, and I will focus more on the development of sustainable material to improve newly proposed customized safety helmet. So aim is to, to develop the safety helmet for agriculture, and that can be used by the plantation workers to protect their head and their body from the bunch falling from the trees. And by having this safety helmet, at least it will, protect to some extent, the plantation workers. So we have done the developmental work. I think it is the Samsdabi's right to whether to implement it or to commercialize it, but we are helping them, or we are working with them rather, to develop this product. I happen to involve as a sub head to develop this oil pump safety helmets. Okay, oil palm empty fruit bunch fiber composite is very promising material to be commercialized, especially for low-cost product. As I highlighted earlier, for aircraft body may be difficult, but low-cost product, yes, why not? Low-cost means cheap raw material and require less energy to manufacture. The material, as many times I highlighted, this is environmentally friendly, and it is green material. Okay, the aim is on the right hand side, look at what happened in the left hand side, no protection for the workers, and wear a hard hat, and we want some protection. Okay, our design team come up with a solution. We brainstorm, we come up with the ideas, we discuss and to develop the concept in design. First we have to have the conceptual design, and using the advanced software, CAD, even final elements, and then we develop the prototype biocomposite helmet. We fabricate, and in this case we fabricate manually. It is to produce some prototype, and we did it by hand layup process. And on the right hand side is the finishing, and we submitted to Samdabi. And this is some example how the product was improved. We tested, and we did some. It didn't fit the accessories in the helmet, and the finishing process. And this is the aim really, and how one day Samdabi will use the product from the natural fiber composite to be used in the plantation. We have submitted the final report, and the product launch took place in 2018, by the then Prime Ministers. And hopefully this product will, be used in the plantation in Malaysia and Indonesia. A lot of potential for commercialization. The aim of putting that history of the story is just to highlight to you that this is not just merely laboratory work, but it has some significance in industries. And I think Knaf is another product that is available in our country. A lot will find, even the center is in Kelantan. Okay, the Knaf was introduced in Malaysia in early 1970s and was recognized as potential alternative fibrous material for pulp, paper, and wood composite industries in the late 1990s under the 7 Malaysian Plan 1996 and 2000. Compared to other plants, the yield of Knaf are higher, thus presenting more economic advantages. For the past several years, Knaf have been shown to be suitable for composite, such as particle board, MDF, wood, ballistic, composite, non-woven material, and pultruded product. According to research results, Knaf yields is greater than those hemp, flax, and jute, thus providing more cost-effective raw material. So I think we in Kelantan we familiar with this one, Lembaga Kenaf and Tobacco dan Tembakau Negara, National Kenaf and Tobacco Board Malaysia, and it is replacing the tobacco and also the considering and also replacing tobacco. And we at UPM also have done a lot of work on Kenaf and Kenaf composite. Okay, as a proof, this is the one book that we published 3 years ago on the Kenaf fiber and composite with CRC Press in USA. It's an edited book on Kenaf. You can always read this in from the library. And you see, this is the Kenaf that used for the composite, for as the fiber in composite. It's comprising the bus and core, and the bus is the outer layer of the Kenaf. And then the middle one is called core. And the mechanical properties of some Kenaf and non-woven fiber, we see that Kenaf, I think I highlighted earlier also, 295 to 1191, the strength, the megapascal, the modulus up to 60 gigapascals, and it's quite comparable to other like established fiber like flex, which is 50 to 70 gigapascal on modulus, and strength is 500 to 900, whereas Kenaf bus even beyond 1000 megapascal. Okay, another research that we carried out on the Kenaf is to incorporate Kenaf with the Kevlar. As I mentioned, Kevlar is the synthetic natural fiber, synthetic fiber. They are very expensive, used in very important application like in military, body armor, in the aircraft body, etc. But our work at UPM is trying to use part of that component in body armor and also in spall liner, one component in the military vehicles, to add some Kenaf in that. So what happened to that? It is for ballistic protection. So is there any effect when we add Kenaf into that? It help, because Kenaf, compared to Kevlar, of course, they are very, very weak, but what are the contributions? So the work was carried out, in association with the STRIDE, Science and Technology Research Institute for Defense Malaysia, MINDEF, and there is a potential to reduce the use of synthetic fiber, in this case, Kevlar, in secondary armor at low impact resistance requirement by partially replacing it with Kenaf fiber to make hybrid composite. Okay, the armored vehicle spall liner. So this, like on the right hand side, you see, I've shown this one. Which is on the spall liner for military vehicles on the right hand side top. So spall liners are composite panels made with a synthetic fiber mounted to the inside of the shell structure of the armored vehicles. They protect personnel inside by catching small fragment of the outer shell blown into the vehicles by the concussion of incoming ordnance before it contact them. Used alone or in combination with metal or ceramic, spall liners help increase crew survivability in combat. So we can see that on the bottom figure, with and without spall liner. And without spall liner, we can see that how the effect, but it can be controlled by having the spall liner. So the aim is to replace part of the aramide with Kenaf. So we have 100% Kevlar and hybridization, which is mainly Kenaf, hybridization C, which is mainly Kevlar, and equally the hybrid D, the amount of the Kevlar and Kenaf, and all Kenaf, where they have some effect. The Kenaf and Kevlar were hand laid up, using manually, done manually with epoxymetric and with some hardness, of course. To thick mild steel plate were used as a mold in the fabrication process. This on the left hand side is the woven Kenaf fiber. On the right hand side is Kevlar fabrics, and we laminated them, and then we can see that the pictures on the hybrid laminated composite after the ballistic test. And we carried out the quasi-static punch shear test. The schematic of this quasi-static is shown on the left-hand side in the figures. Quasi-static penetration resistance was conducted to study the penetration resistance of composite. It focused on penetration process, penetration resistance, energy absorption, and also the failure of hybrid laminated composite. So in this study, the experiment was carried out to understand the penetration behavior of Kevlar hybrid laminated composite under quasi-static condition. This one is a static condition, but this is on ballistic impact. Yeah, ballistic test, actual setup for ballistic test, and B is a schematic test setup based on the standard associated to this with NIJ standard, 0.01 standard NIJ is used as a reference. The ballistic impact experiment were conducted on Kevlar hybrid composite to determine the V50 ballistic limit and energy absorption. The ballistic test was conducted in indoor firing range of 9 millimeters, 8-gram bullet, which propel at the target using the powder gun approximately following the standards. Okay, this is the result. Well, we can see that the ballistic limits, the all Knaf, they are the inferior, the all Kevlar is, of course, they are the best. Hybrid B, C, D composite recorded lower than Kevlar, epoxy composite, etc. The difference in ballistic limit in hybrid composite, which consisted the same number of Kevlar fabric, denote that negative effect of non-woven Knaf hybridization with Kevlar. So there's some negative effect. The penetration damage behavior of surfaces, rear, front face, and cross-section of samples. This is shown in the figures. And this is show the damaged surface of composite after ballistic test. So meaning that why we have to include the Kevlar, the Knaf in Kevlar. Of course, in certain cases, when the specification is achieved, can be fulfilled, so certain amount of Knaf natural fiber will help in terms of reducing the weight or even reducing the cost. Despite strength is concerned, they are dominated by the Kevlar. So we carried out some work on ballistic, and we published a book with our collaborators in National Textile University in Pakistan, which is soon to be published by Elsevier, Composite Solution for Ballistic. Okay, I would like to highlight some. This is a current work, in fact, with the Steelcase and Berhad. It's international furniture manufacturer. I mean that they have the office in factory in US, and also Malaysia happen to be the Asia Pacific's office. Steelcase, the work are funded by them. This is really serious work. We want to produce chairs from Knaf. But as I mentioned earlier in my lecture, the PLA is used as the matrix, and from my reading, PLA is a good biopolymer. It's not as weak as like starch that we starch may be good to be used for packaging and good packaging, but for PLA they are serious work and to use as the structural component. In this case, the component for the chairs, and the company approached us, give some money, and we did some work for them. And Knaf fiber with PLA, we prepare the material. Initially, we do some extruding using twin screw extruder. We did some injection molding and test the composite. And later we want to use this finding, and whether or not they fulfill the specification of the chair that are used in the company. So we extend this work also to hybrid it with bamboo. Currently, still under preparation, under discussion. So this is more pictures on the development of the PLA Kenaf biocomposite for chair using the screw extruder, and we chop the fibers, and then on the right hand side is 80% PLA and 20% Kenaf fibers. And this is other more product, and the testing was carried out like universal testing machine for tensile flexural testing. Okay, I would like to highlight the work on biocomposite, which is really successful. We call it Putra Frame. That's funded by the Bersama UPM. I headed the project. I say this was a successful product that we commercialize it in. We make it in house, and we commercialize it, and people like this product because they're unique. And you can see the side view and the front view, and even the packaging, nicely packaged. Okay, the biocomposite from this product is made from, again, the injection molding, but now the Kenaf is taken from Kenaf core, the center part, and we use as I mentioned again, synthetic polymer is used instead of PLA in the previous example. We still have to rely on synthetic. At least Kenaf is there in the green materials, and we make into biocomposite. And biocomposite is injected into injection molding to produce our Putra Frame product. And this is how the assembly and packaging of Kenaf composite frame took place in our lab, assisted by some students as well as staff, and nicely packaged, and we commercialized it successfully. And it was launched in 2018 by then the Minister of Agriculture during our convocation. The second natural resource that I want to focus in this lecture is on sugar palm, or Arenga pinnata urumme. So I think many of you not familiar with this plant. Well, I think we in the Malay society, we know that this is gula kabung. This is where you can get gula kabung from here. During Ramadan, in some places in Malaysia, we use as belolo. Kolang kaling in Indonesia, we put in our ABC or for our buka puasa. And this is the fruit that we see on the left hand side, but we more focus on the fiber. So the fiber from this sugar palm plant is very good. This is quite unique. The longer one selling point that initially why we interested in this product, the longer we soak in the water, whatever type of water, sea water, swamp water, even plain water, the longer you soak, the better the performance, the durability, the strength. And that's why in Indonesia, we visited in Indonesia they are very advanced in this technology. The whole village, they use the roof from this fiber, and they said it can stand until 20 years. And even in the past, during the Sultanate of Malacca, they used this as ship cordage. Even in the past, when British, was in Malaysia, they used this as a food cordage as well, and to make sampan. And the previous, people in the past, in our forefathers make it. They put it in the water. And so the property of sugar palm, the density, of course, natural fiber is low, and tensile modulus and tensile strength, they are, respectables. And as a proof that we have done a lot of work, so we publish books on sugar palm biofiber, biopolymer, and biocomposite, which RC Press also in 2018. So we compile a lot of work. Majority of the contributors is from our research group. This is the outcome of about 20 years of the research that we carried out on sugar palm and sugar palm composite. Okay, one recent product that we developed was the fabricated solar module. It is done with Dr. Aladdin. He's from Gaza, and he just completed his PhD. Modules, while exposed to sun radiation, the front view of the module, But C, this is what we're interested in, back view of module showing the seal backsheet, where we have some kind of sugar palm fiber composite as one of the layers. Okay, you see the schematic diagram of the proposed solar modules, including utilized component and functional parts. Tempered glass in encapsulant film, solar film. This is existing one, encapsulant film again, but this is our product, our material. This is a PVDF, one kind of advanced polymer, SSPF, in short sugar palm fiber composite. This is the product that we developed. Okay, this product has been, protected by copyright, and I think I was promised by somebody that the company want to discuss on whether or not we can commercialize this product after Hari Raya. That's it. Okay, we publish in a good journal like in Journal of Cleaner Production, and physical and mechanical property of polyvinyls, Eden's fluorides and short sugar palm fiber biocomposite. So some finding from that is that the work is to prepare, produce, and investigate the mechanical, nanomechanical, physical properties of PVDF reinforced with a short sugar palm fiber composite. And we, of course, use the hot press and mixing process, and we carried out the testing on the flexural and impact and physical properties like density, water absorption, moisture content, and thickness swelling. And the result is that mechanical properties displayed good flexural and tensile enhancements, and the use of short fiber led to adequate interfacial bonding between fiber and matrix. The composite exhibited outstanding physical properties and excellent resistance to water and moisture content and thickness swelling. Okay, this is the development toward making the solar panel lightweight and durable. PVDF, the sugar palm starch fibers, sugar palm fiber composite for photovoltaic backsheet application. We carried out the thermal and optical testing, and then, of course, when we talk about thermal, we have redid the TMA, TGA, DSC, and optical also is another process testing that we carried out, and even including FTIR, Raman spectroscopy, in situ scanning probe microscopy, and all the advanced the equipment that we use. And also, when we develop the photovoltaic modules with fabricated novel backsheet biocomposite materials, we reported it and we published in Materials Journal. The detail you can find in this in this paper. Okay, now this is the work, collaborative work with Proton, our cars, our national car, to develop the glass fiber and sugar palm hybrid composite for anti-roll bar. The project is fully funded by UPM, but we invited Proton to be our collaborators. They give some advices, some drawings, and some advice in how to develop this product. Okay, the motivation of this study is to determine the ability of sugar palm in substitution of alloy steel in application of automotive component. Is it possible? Well, we are doing research. We are doing fundamental research. We try to prove that it is viable. This is the red. In red, in color, is the product. I think you may be familiar with this one. The existing material is using carbon fiber composite or AISI 1030, the materials, and they are all with metals. But my research team was entrusted to carry out the conceptual design, because this is one of my expertise. And other groups, they are making product, develop the prototype, do some testing, but we focus more on the conceptual design. Well, this is really like arts of the rather than engineering, rather than the hard science, but in design, in development, this is also required, and we carried out the identification of voice of customer and voice of environment, and we carried out the weighting of voice of customer and voice of environment, and we carried out material selection of natural fiber and matrix, and this is the 3 activities and additional activities. We carried out the conceptual design and development of the product of the anti-roll bar, and we carried out also manufacturing selection process using software system expert choice under the AHP analytic hierarchy process. Okay, in design, I think if any of one of you here, engineers, mechanical engineers, we have to generate the idea, select, develop the idea, and select the best concept. And using the different techniques like function specification using trees method, force identification using free body diagram, method selection using quality function deployment for the environment, and analytic hierarchy process, and we use for method selection, failure mode identification using trees, cause and effect chain analysis in trees, and geometric determination, engine contradiction, and invention principle using trees. And we use the blue ocean strategy for marketing for business into our research. And it's something that we introduced, and it was accepted by Q1 journal. So we did the concept development using morphological chart and concept selection to get the final concept of design based on product design specification using analytic hierarchy process. These are some of the results, which is conceptual design, development, and selection. We managed to get the 42 concept as the final, and then we select the best out of those 42 concepts. Okay, our colleagues, from different the same team that I become the principal investigator, and they carried out the head of sub project. They carried out the publication process. They use this is the preform, meaning that preform is the the material, the composite is not ready for the semi-cured composite preform of hybrid glass and sugar palm fibers for glass and sugar palm reinforced hybrid composite for automotive anti-roll bar. So from this preform, we put it into the mold and make into the component. So this is the product, the fabrication process using vacuum assisted resin transfer molding, VRTM, to develop the product, and this is the final product. Of course, it's a big project. It's 500,000, 600,000 worth of project, but I just highlight on the certain aspect of that project. Okay, this project also is important project because it's on the characterization of sugar palm nanocellulose sugar palm starch biocomposite, meaning that this is why I said earlier, 100% from plant based, meaning that as like in PLA case for the chair, same thing with this one, but this is for packaging, to put packaging in nanocellulose. I'm not expert in nano composite, but my student, he interested to explore this, and they got grant from the FRGS. So the starch, the biopolymer starch biopolymer is from sugar palm, and also the fiber, they make it in the form of nanocellulose, also from sugar palm. Okay, the project just completed. In fact, before this project, we have done a lot of preliminary work on sugar palm starch. For example, Dr. Sahari, the late Allahyarham Dr. Sahari, has carried out on the testing of sugar palm starch and sugar palm fiber, also carried out by Allahyarham Dr. Sahari from UMS, and sugar palm cellulose carried out by my former student, Dr. Lamin Sanyang from Gambia, and sugar palm nanocrystalline and also nanofibrillated cellulose was performed by my former student, Dr. Ilyas, now in UTM. And this is how the work developed. And the recent work, this is very important work that we carried out, and it's highly cited work. Recently, this work, one of this paper, we got the awards from the Perintis Malaysia Muslim Scientists Association Society. They give us the best publication award. based on this project. Okay, development and characterization of sugar palm nanocrystalline cellulose reinforced sugar palm starch biocomposite, meaning that the polymer is from sugar palm, the fiber is from sugar palm in the form of nanocrystalline cellulose. Okay, I'm not going to into detail how nanocrystalline and nanofibrillated because it's too detailed, and many of you are not chemical engineering background, so I also not. So this is Dr. Ilyas has carried out and taking the stem, the fiber, the starch from the stem of the sugar palm. Of course, this is quite tedious work, and normally this starch is made to make a flour and delicacies, but now our research team try to produce the starch and to make it sugar starch biopolymer after adding some plasticizer, in this case sorbitol and glycerol, and we have also added the starch with fiber, which is using the homogenizer. So we managed to produce the very fine nano scales, nano size nanocellulose, and we mixed with the sugar palm starch to make the sugar palm nanocellulose reinforced sugar palm starch composite by the process called solution casting. Okay, this is some of the example of this SEM micrograph of raw sugar palm fiber A, B sugar palm bleach, the fiber, and sugar palm cellulose. Okay, I don't have much time really. I got only 2 minutes really, but anyway, I try to. Okay, the work is extended to include the cinnamon essential oil, to study the antimicrobial. Is currently one PhD student is working on that. And of course, cinnamon is the essential oil is the something that is extra, and I think the result is given here. Okay, in biocomposite during COVID-19. Okay, I think we may interested in this. We may be interested in this because of the current problem we are facing, and a lot of people die, and then also the spike of corona cases has contributed to the shortage of face masks. And there are issues related to that, thus increasing the demand and supply of petrochemical-derived personal protective equipment. Okay, because of that also, as I mentioned in my first second slide on the environmental problem, pollution, and there are a lot of effort they are made to develop biocomposite product, during this COVID-19. And one of them is in Italy, for example, they use a smart operating shelter project using the fast-built mobile healthcare structure using biocomposite panels. This is the example, biocomposite panel from recycled PET and bio-based polyurethane to make the panels during the COVID-19. And this is another work on bio-based face masks, using the gluten as bio-based face mask raw materials, and herbal extracts such as tea tree oil, and they're also being used for good antimicrobial activity. This is not biocomposite; it's part constituent of biocomposite, and where the product is polybioskin is made from polylactic acid. I highlighted earlier starch, cellulose, which are really the constituent of biocomposite. And the recent work by the Biocomposite Center in Bangor University, they use the crab shell just to protect the NHS staff from virus. They are from Biocomposite Center, but this is from Kaitosan. They are not making into biocomposite, but they make that crab shell to protect the virus. Okay. And also biocomposite as the disposable bed sheet, assisting in minimizing cross-infection risk emanating from linen washing, biodegradable and compostable and stain-resistant and lightweight. Okay, this is another example, biocellulose mask. 3D printing technology is used for that. But I want to focus, I think, the last few minutes of my lecture on the sustainable green technology by way of transforming this disinfected COVID-19 non-woven polypropylene waste into briquette char through pyrolysis process. This is as soon as that the COVID-19 start, the minister invited me to develop this, to come up with the project. So, and we use polypropylene and gown to make char reinforced sugar palm starch biocomposite. The objective is to determine the optimal carbon char yield as a PP pyrolysis product using different pyrolysis temperature, and we use sugar palm as the matrix. And this is the schematic of the project. Healthcare, we take the gown and then we pulverize the gown and then get the PP waste powder. We do some pyrolysis process. We add, and then finally we get sugar palm, the char, and we add with sugar palm starch, and it can be used. The sugar palm char SPS, sugar palm starch composite, can be used for barbecue, fertilizer, water treatment, etc. This is more detail on that project. I think I'm not going to detail. I just show the pictures. This is how the pyrolysis process took place, and this is how the crushing work took place. And again, pyrolysis reactor, and how the composite was made in the mold, hydrate press using molds, and as again repeated from the earlier one, can be the fuel application, absorbent for water treatment, and acid treated char has higher surface area for non-filler and sensor application. And as far as strength, the compressive strength, they are good, and also the heating value also quite respectable. So we found it, the result is significant. And this is the again further result from SEM. And finally, I think I just only 4 minutes. Exceeding my lecture for 4 minutes. So I just want to highlight some recent book publication that we published. Composite Material Concurrent Engineering Approach by Bertels Hanneman, and Advanced Processing Properties, Application of Starch and Other Biopolymer. This is published last year. It is edited book. On the right-hand side is an authored book. Left-hand side is an authored book on the conceptual design of biocomposite. And this is on the left-hand side is the edited book. This on the grain materials, and this method selection for natural fiber composite and tropical fiber composite. They are authored book and published by international publisher. And this is our recent book on composite in biomedicals, natural fiber reinforced vinyl ester and vinyl polymer composite, biocomposite and synthetic composite for automotive by Elsevier. The middle one by the Elsevier also. The left-hand side by Taylor and Francis, CRC Press. And we published recently in January, last month, bio-based packaging. During Ramadan, it was published by Wiley. It's a thick book. And 2 books on green biocomposite by Springer and manufacturing of natural fiber composite by Springer. And we published also method selection design. And Rossell composite is going to be published very soon in US. And also we published mineral field biopolymer 2 books, 2 series, and design for sustainability also published last month, and biofiller reinforced biocomposite early this year. And there's also the books in natural fiber green biocomposite part 2, and hole making for and drilling for manufacturing for composite, and also the neural network in composite technology. So there is some review of the book that we published. Maybe we can read the books on biocomposite. And I'm chairing this session, this conference for the 5th bio wood and biofiber international conference in November related to biocomposite. And also our society, we developed the one society. The founded one society of Sugar Palm Development Industry of Malaysia, and we're also organizing a conference in December, end of this year. With that, ladies and gentlemen, I would like to conclude my lecture. Research work on biocomposite is limited, really. Biopolymer composite is another emerging composite research that we at UMK and UPM can work together, and also, it's become, very rich area of research. Our natural fiber resource still underutilized. In Jelly area, I've been there in December. A lot of things can be explored. High impact bio composite research and industrial and community services are equally important to transform our natural resource into circular economy. Finally, I would like to thank UMK, the organizing committee of the IConBET2021 for the invitation, UPM for research specialties and research grant, Ministry of Higher Education for research grant, Steelcase dan Berhad for research, the contract, and then research Samdabi for research grant, and my PhD student, particularly Muhammad Harusani, who helped me in making this PowerPoint. With that, ladies and gentlemen, I would like to thank you for your attention. Thank you so much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much to Professor Muhammad Safwan Saleh for his informative and interesting talk. Right, so with a great achievement and outcome from the research, such as a product, of course, again, the papers, and then the books. I think a lot of books they publish. So, okay, ladies and gentlemen, now we come to the questions and answer sessions. So, Prof, maybe you can have a few questions from comment room, Prof.
Yeah.
Okay, the first questions we have from Nohidaya. Okay, Nohidaya and Ilyas. So, Prof, is there any research related with fiber from leaf of oil palms?
Oh, leaf, leaf
Yeah.
of oil palm. Okay, oil palm leaf, because you see, I'm not very, I didn't go into detail on oil palm really. I have some work mainly on the from front and other product. But as far as leaf is concerned, I'm sure there is work on that, because even banana leaf people use that as the fiber. In fact, for natural fiber research, the source of natural fiber can be from anything, even from waste paper, newspaper waste, even for anything from the from sawmill. We can get this powder, even can be used. I think for the leaf of oil palm, I'm sure that researchers have done work on that, but it is potentially can be used, because they have got, even they have the mechanical properties good, the strength and stiffness, but they still can be used, to reduce cost in certain product. I think yes, my answer is yes.
Okay, thank you, Prof. So we have another question from Temitiu. Hi, Prof. How about the development of knife fiber as biocomposite material in building constructions, material production in Malaysia?
All right. The one, a lot has been done. I think UITM, they have got some, work on that. Even they commercialize. I think 2 years ago we organized a conference. One of the speaker is, from industry, and then associated with UITM. So they have made into, the product, the house, from that, the building construction materials. Even in Trop, in our, at UPM, where the center I'm working, some researchers, they are working on the building material for panels, etc. Yeah, I think the answer is yes also again.
All right. Okay, thank you, Prof. And then next we have from Faisal Wan Isha. Any research related to bamboo as raw material as a composite?
Oh, bamboo, yes. I think, this is a national agenda. In fact, I was interested by, we are high COE. Introp is high COE. I'm one of the head of the, lab. So specifically, I was interested to work on the bamboo composite. This is from Ministry of Higher Education, that you have to work on bamboo. Yeah. And then I think in addition to that, there are a lot of research like UPNM, even in Trop, in the Department of Aerospace Engineering UPM, they use the bamboo. They test the bamboo for building material, or even for aerospace component or anything for many products. But mainly they carried out the testing, the coupon test, and then once they got the information on the properties, and the application will follow suit. Any industry that interested, it can be channeled toward that. Yes, certainly yes. A lot of work in the past, and we are also working on that in bamboo. And I have one PhD student working on the bamboo for the helmet, for the cycling, for the bicycle helmet. Yeah, cycle helmet.
Okay. So next we have from Hidayah as well. So how about the research on Bertam fiber from Bertam leaf, Prof? Any comment on
Yeah,
that?
Bertam, I have my student, PhD student. He's a professor now in one university, and after he finished his PhD under me in 2010, and he went back to his university and he supervised one PhD student on Bertam leaf fiber composite. I don't know whether the work is completed or not, but I'm sure they're working on Bertam leaf. Yes.
That Bertam is mostly found in Indonesia or about in Malaysia, Prof? The
No,
Bertam
you
leaf.
find in Malaysia. You find it here in Malaysia.
Okay. Okay, so now we have from Camelia Kong. So good morning, Prof. Also, thanks for your interest. My question is, since the research focus on producing environmental friendly product using natural fiber, are there any effort carried out the process itself if environmentally friendly? How about the process?
Well, this is quite a long question.
Yes,
Just
Prof.
my question is.
They
Okay,
ask about,
I think I addressed in my lecture. There are two parts. One is on the, using synthetic polymer composite and using bio-based polymer biocomposite. Now the move is towards making 100% bio-based, the natural fiber composite. Well, synthetic polymer, we cannot just disregard it, just discard it immediately. This should be some stages. In the past, we have only 100% synthetic composite. Now we have natural fiber and still synthetic polymer. But as I mentioned, using PLA. PLA is it's not synthetic. PLA is the plant based, from corn, maize, etc., soy, and this is a biopolymer. And we mix with, for example, kenaf. This is 100%, and the process still, whether you use the 100% bio-based polymer composite or synthetic natural fiber composite, you still have to use the same machine like injection molding, compression molding. But if you use solution casting, for example, to make the packaging, for example, and the potentially for packaging, food packaging, they are using solution casting. This is the fabrication process, which is 100% bio-based polymer composite. Okay. I think the effort is toward that. The move is toward that 100% bio-based polymer composite. But as I said, you cannot discard altogether. You have to be step by step.
So that's mean we can achieve the 100% environmentally process.
No, we have done it. We have done it. Not just achieve. You can think about PLA plus, kenaf. This 100% already biocomposite.
All right. Okay. Thank you very much, Prof. Okay. So I think that's all the question from comments room. So maybe I have one question from me myself, Prof. Just your advice to young researcher or young academician to be excellent like you, Prof. So any advice or recommendation, suggestion from you, Prof?
Yeah, I think whatever you do, you try to do it properly. You may not get a lot of chance, but you are given chance to become master student. Do it properly. Do it to the best of your ability. Try to publish in a top journal. Even if you have opportunity, try to patent your work. Even copyright. Protect it by copyright. Present it in conference like this. When there's opportunity, you go for it. Because once you start with a little small thing, and the bigger thing will come. Yeah, and I started that way. Whenever I got one student, I will work with the student, publish in a good journal, try to get patent or not patent, if not patent, copyright, and present in conference, do research properly, and try to get a graduate on time status, GOT status, even before time. So master's 2 years, try to do it in 1 year and a half or so. And this is give you an indication of excellence. I try to apply for awards, for competition, 3-minute thesis, and so many meta literature competition, published in conference. Nowadays conference are free, mainly online. Many are given you for free. Don't waste this opportunity. Take full of this, and then when your CV is built up, and then you can always apply for a good job and try to improve and try to enhance your career.
All right. Okay. Thank you very much, Prof, for your for your answer, for your suggestion, for your advice. Okay, ladies and gentlemen,
Welcome.
finally we come to the end of the presentations. I'd like to say thanks again to our presenter, Professor Engineer Dr. Safwan Saleh, okay, for the informative and interesting talk, and to the audience for your active participants. Okay, hopefully the presentation will be beneficial for everybody. Thank you for your attention, and Assalamualaikum warahmatullahi wabarakatuh, and see you again.
Assalamualaikum.